Hey everybody, so this video is about projectile motion. So it's 2D kinematics, but kind of a specific example of it. So let's say, for example, you kick a ball, right? And then with some initial velocity, what will happen, right? It'll go forever in a straight line if there's no acceleration. But if there's gravity, this way, vertically down, right, then that acceleration is going to change this velocity, and then the ball is going to go like that. And let's say you pick coordinates that look like this. Right, then you think to yourself, okay, and then you kick it at some angle. You just think, of all the formulas I know in the world, what applies to this situation? Right, so you're like, okay, it looks like there's acceleration vertically, and this is a constant, so it's kinematics or constant acceleration. It's two-dimensional, so nothing you haven't, right? Just like this. And then in the y direction, and then for velocity, in the x direction, like this, y direction. Okay, so then this applies. The values you put here, 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 here will depend on your choice of coordinates, though. So let's practice. Let's say, what is v naught x? What are the x and y components of this vector? Right, so the x-axis is here. So the x component of this vector is right here, right, which is positive, and then it's adjacent to the angle, right? So positive and adjacent means cosine. Okay, what about the y component? Y is here, right? So the y component is here, which is opposite the angle. So then opposite sine. Okay, how about acceleration? This and this, right there, this. So what's the x component? What's the y component? So x is here. The only acceleration we have is gravity going vertically, so that's x is 0. And then if y is positive going up, and then gravity is going down, then this is negative. Okay, so again, this is not to memorize. This is specific to this picture, right? That choice of coordinates. This is still true, right? It's kind of generically true. But let's say, what if you picked coordinates like you kick a ball, but then you want to pick coordinates maybe like, how about like this? All right, nothing wrong with that. So, but what is gravity is this way. So what are the x and y components of this initial velocity now? So x is this way. So the x component is here, right? So it's negative. And then see how this is opposite? So sine, right? And then the y-axis is here. So the y component is positive, but then over here, right, which is adjacent to the angle. So positive cosine. Okay, and then how about acceleration? X is here. Gravity is going this way, so that's positive g. Y is here. There is no acceleration in y. Right, so look, these are different already. Same situation, kicking the ball, but different choice of coordinates. Okay, let's go maybe one more choice of coordinates. Let's say you kick the ball like this, and you decide, I'm going to pick coordinates like this. Okay, so then what is this? what's the x component of this vector? The whole thing, right? It is in the x direction. What's the y component of this? 0. So that's a pretty convenient choice of coordinates as far as the initial velocity. How about for gravity though? This way, right? This way, vertically down. Okay, now like which of these is theta? So in your mind, or you can just draw it like this. You see how it goes from the horizontal dashed line to this solid red line counterclockwise, theta, right? So the dashed line counterclockwise to the red line, dashed line counterclockwise to the red line, dashed line counterclockwise, dashed line counterclockwise to the red line. So you basically take this coordinate system and rotate it counterclockwise to the red coordinate system, right this way, counterclockwise. So remember that strategy. Now look, we know that the angle is right here. So if we want to decompose the acceleration into x and y, x is here. So look at this, that's in the negative x direction, right? And is opposite the angle. Opposite means sine. Right? How about y? Y is over here. So g is in the negative y direction and is adjacent to the angle. Cosine. Okay, so look, right? This is not to memorize, right? This is just because of how we pick the coordinates. But you need to maintain that flexibility in how you choose your coordinates. Okay, so let's do some more examples in other videos. I'll see you on those.